Hi everyone, and welcome back for another fun science lesson with the naturalist educators at Chucky Meadows Parks Foundation. I'm Bradlyn, and today we're going to learn about the greenhouse effect. So, what is the greenhouse effect? The greenhouse effect is a process that occurs when gases in Earth's atmosphere trap the sun's heat. This process makes Earth much hotter than it would be without an atmosphere, and is actually one of the reasons that life on Earth is able to exist at all. How does the greenhouse effect work? Well, just like a greenhouse. During the day, the sun shines through the Earth's atmosphere, which warms the Earth's surface. At night, without the sun shining on it, the surface cools down, releasing that heat back into the air. Some of this heat is trapped by gases like carbon dioxide, methane, water vapor, and chlorofluorocarbons before it can leave the atmosphere. This heat is instead radiated back towards the Earth's surface, which warms the planet even more. So today we're going to do an experiment that demonstrates how the greenhouse effect works using some items you probably already have at home. So to do this experiment, we just need a few things. We just need a glass Mason style jar. Just make sure it's a clear jar. 2 air thermometers, a pencil, a piece of paper, in a sunny area outside. So go ahead and pause the video now, go collect these items, and I'll be right here waiting for you when you get back. Welcome back. So now to get started on our experiment, the first thing we're going to do is set our thermometers out in the sun. So we're going to set them out in the sun for about 3 minutes, just so they get acclimated to the temperature and that they read the same temperature. All right, while we're waiting for our thermometers to get acclimated to the temperature outside, let's go ahead and make our data sheet. So you can see I've already made mine. We have 2 columns, thermometer A and thermometer B. And basically we're going to be checking the temperature of the air every minute for 10 minutes. So we'll go ahead and label down this side the number 0 through 10. So go ahead and take a moment and do that yourself. All right, so now that our thermometers are all warmed up, let's just go ahead and label them so we can make sure we remember which one's which. So we're just gonna write the letters A and B on them. So we'll just put A for thermometer A and thermometer B down here. And while we're down here, we're gonna go ahead and grab the temperature reading from these. So thermometer B says it's about 92 degrees Fahrenheit. And thermometer A also says it's about 92 degrees Fahrenheit. All right, so let's talk about that for a minute. So 92 degrees Fahrenheit is obviously a really high temperature. And we can tell it's not 92 degrees outside right now. And the reason that our thermometers are getting a higher reading than the air temperature is because they're sitting outside in the sun. So the sun is warming them up directly. Have you ever been surprised by how warm a slide is at the playground? It's very similar to that. Because the slide, or the thermometers in this case, are sitting in direct sun, they're going to warm up faster than the air. All right, now that we have the base reading for our thermometer and we wrote it down on our data sheet for time 0, let's go ahead and get our experiment started. So we're going to put thermometer A into this glass jar, and this is going to act as our greenhouse because the heat from the sun is able to enter the jar, but it can't escape because it's a closed lid. So we're going to set that here and leave our thermometer B. We're going to set it against it and make sure again that neither thermometer is in the shadow. And then we're going to set our timer for a minute, and we will check the temperature of our thermometers every minute for 10 minutes. All right, it's been 1 minute, so let's go ahead and check our temperatures. And we have thermometer B at about 100 degrees Fahrenheit. So let's go ahead and write that down for time 1. Let's see what thermometer A is at. That is also at 100 degrees Fahrenheit. So we'll write that down as well. So go ahead and continue to do this. Check your time, check your temperatures every minute for 9 more minutes. been 10 minutes, so let's go ahead and grab our final reading. So our thermometer B is at about 92 degrees Fahrenheit. And our thermometer A is up there at 111 degrees Fahrenheit. Now it's time to analyze our data. First, let's talk about thermometer A. Thermometer A started at 92 degrees Fahrenheit at time 0, and by the 10th minute, the temperature in the jar reached 111 degrees Fahrenheit. How about thermometer B? Thermometer B also started at 92 degrees Fahrenheit. The temperature then increased and maxed out at 100 degrees Fahrenheit before decreasing back down to 92 degrees Fahrenheit. Why did the temperature increase? Well, probably because the thermometer was still getting a lot of direct sun. Once we moved the thermometer to be propped up against the jar, it received less heat from the sun and started to cool back down. So, what do we notice about this data? Clearly, thermometer A reached higher temperatures in the jar. It also stayed at that high heat, while thermometer B neither reached as high of a temperature as thermometer A, nor did it stay at its highest temperature. The reason that thermometer A got so hot and stayed there is because of the greenhouse effect. Heat from the sun's rays penetrated the glass to heat up the air inside of the jar. But this hot air had no way of escaping the jar because we had a lid closed tightly on it. In this simulation, the Earth is inside of our jar, and the lid is our greenhouse gases. Without the greenhouse gases, or lid in this case, heat would be able to escape the Earth. However, when the lid or greenhouse gases are present, heat is trapped inside of the jar, or on Earth. So, what are these greenhouse gases and where do they come from? The main greenhouse gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. These gases are produced by the combustion of fossil fuels for transportation, industrial processes, electricity, agriculture, and commercial and residential uses. Overall, greenhouse gases are beneficial to Earth because without them, the planet would be too cold for life as we know it to exist. However, there can be too much of a good thing. Scientists are worried that human activities are adding too much of these gases to the atmosphere, keeping more heat on Earth and contributing to climate change. Human activities since about 1750 have caused a 45% increase in the atmospheric concentration of carbon dioxide, with the majority of carbon dioxide emissions coming from the combustion of fossil fuels. Now, we can think of ways to reduce our own personal use of fossil fuels through habits such as limiting our gas-reliant transportation, turning devices off when not in use, and choosing items produced with renewable energies when purchasing. Leave us a comment below with one way that you limit your own personal use of fossil fuels. Thanks for tuning in for another Chuckie Meadows Parks Foundation science experiment. We hope you had fun learning about the greenhouse effect. If you try this at home, be sure to share your results with us on Facebook at Chuckie Meadows Parks Foundation or on Instagram at @TMParksFoundation. Have ideas for other experiments or science lessons? Leave us a comment below with your ideas. Until next time, don't forget to be a steward.